Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 40 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you guys to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Elite Explorer Kit. Now, most of you guys probably already have your gear. If you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. This is a follow-on lesson to the lesson we had last week in lesson number 39. In lesson number 39, I introduced you to the concept of Arduino functions. What is the concept? You take a complicated job and you break it down into simpler jobs so that you have logical chunks or logical functions, and then you just call those functions. Makes the code easier to read, makes it easier to debug, makes it easier to understand what's going on. Plus those little modules, those little functions that you develop, you can save them and use them in other programs later on. So if you come up with a really good way to sort, you can have a sort function, and then you can go out and you can use that sort function anytime you want to sort some sort of list. And so really functions are very, very useful. Now, to introduce the concept last week, what I did was I did it using global variables. And in lesson number 38, I explained the difference between global and local variables. Well, if we use global variables, it makes it very easy to do functions because everybody is sharing all the variables. Anybody can read them, anybody can write them, anybody can do anything they want to with them, which makes it very easy to program. But things could get very complicated and could get messed up. So like if I had one function that went in and sorted a list of grades and another function that went in and dropped the two lowest grades out of the array, all of a sudden things could be confused because this guy's thinking I've sorted the whole list and this guy over here had already dropped the two lowest grades off of the list. So it's much, much better. And in general, when you're doing functions, you want to do your functions using local variables. So the variable that I use in this function is unique and local to this function. The variable that I use in this function, the variables are unique and local to this function. Then what we've got to do is we've got to pass our parameters, we've got to pass our variables from the void loop down into our function. The function does something and then returns a value. So everything is kind of like, you got to imagine a football, and the void loop passes that football to a function. The function catches it, maybe does something with it, and then throws it back, and then the void loop catches it back. So we are passing parameters between the void loop and the function, or between one function and another function, but we're very deliberate and mindful of the way that we handle our variables. And so that is what I am going to do today. I'll show you how to do that. And this is really the right way to do it. Why did I do it the not so good way last week? Because last week I didn't want to overwhelm you. I didn't want to make it too complicated. So I said, let's understand functions. And then this week, let's understand how to use them more correctly or more perfectly. Let me get out of your way and have a little sip of my coffee. Let's come over to our code view, and now I'm going to show you a more perfect way to do functions using local variables. So let's start with a fresh, new, minty void IDE, And this is the bare minimum. Yeah, that's what I was trying to think, bare minimum. And normally we would come up here at the top and just start declaring all of our variables, but not today. We're not going to define anything at the top or declare anything at the top, because if we did, it would be a global variable. And I'm going to show you how to program without using global variables. So we're going to come down into the void setup, and we're going to do a serial.begin like that. And I'll go ahead and do 115,200 just because I can. And then I will put our friend the semicolon. Now we're going to come down in the loop. I guess I should say, what program are we going to do? Well, you're going to have a rectangle. Okay, you're going to have a rectangle. That rectangle is going to have a length and a width. Who do you get the length and width from? You get the length and the width from the user. Then once you have that, what you do is you go in and you calculate the perimeter, you calculate the area, and you calculate the diagonal. And we're going to do it using functions and using local variables. So we're not going to define our variables up at the top. I'm going to define my variables in the void loop that will be local to the void loop. So what am I going to need? Well, I'm going to need a floating point number for the width of my rectangle. I'll need a floating point number for the length of my rectangle. I will need a float for the area of my rectangle, and then a float for the perimeter of my rectangle, and then a float for the diagonal. What is the diagonal? That's the length from the upper right corner to the lower left corner, the diagonal. Okay, now what am I going to need to do? From the user, I'm going to need to get the length and the width. So I'll just do that in the main program. So what I'm going to do is, how do we get input from the user? Three things. We ask, we wait, we read. So I'm going to ask serial.println. Println helps if you spell it correctly. And then I'm going to say input length of rectangle, like that, colon, like that. So I have asked. Now what do? I wait while serial.available open close equals 0. Okay, while there's no data input, what do? Absolutely nothing. So I just open and close the curly. Okay, I don't do anything at all. I just sit and hang until data comes. Once data comes, what do? I read it. So I'm going to say, I ask for the length, so I'm going to say length is equal to what? Serial.parse float. I'm reading a floating point number, and I define length as float. So I'm going to parse float, open close, and then that is going to read that number from the user. Okay, so I now have my length. What else do I need? I need the width. Well, that's going to be almost the same. So I'm going to come and I am going to snag all this code, not including the this curly closes the void loop, so I don't want that, but I want the ask, wait, read. So I will copy, and then I will come here and I will paste. And so then this now, instead of length, now I'm asking for what? The width is equal to serial.parsefloat. That seems like an awful lot of white space in there. Okay, so let me take that out. Let me take that out. All right. And now I'll put that one back in. Okay, so now I'm going to ask for the length. This time, this is what I just pasted. So this time I'm going to ask for width, and then here width is equal to serial.parsefloat. So length, parsefloat, ask for length, ask for width, and then width I'm going to read. Okay, so that is all very good. Now, in the past, what I would just do, if these were global variables, I could just come in and I could create a function find area and then open close, and then it would go down and it could say area is width times length because they're global variables. But this time I'm not doing that. Okay, these are local variables. So I have to pass it. I have to pass this function what two things. I have to pass it length and width, like that. All right. Now, this is not going to be a void function because not only am I going to pass length and width down to it, I have to pass back up what? Area. So how do I do that? I am going to say that area is equal to find area of length and width. Now when I'm down and I'm defining area, when I'm defining it, I have to put in the function a return. What am I going to return? I'm going to return the area that was calculated. It's going to return right here, and then my area as known in the void loop is going to be set to that value that is returned from the function, if that makes sense. Okay, then let's see. I'm going to go ahead and print here. I'm not going to do a show results type of function. I'm just going to print it as I get it because I think it'll help you understand a little bit if we go ahead and do it here. So I'm going to say serial.println like that, and then I'm going to say your area is like that space, and then I'll put a comma, not a comma. I will concatenate that with the string. I will calculate that with the string value of the area, like that. Okay, now if I am going to define this function, find area, I've got to come down here after the end of the void loop, after that curly closing the void loop, and I've got to create the function. Now, in the last lesson, we were doing void this and void that, void function name, because we weren't returning anything. It was void. We weren't returning anything. We were using global variables. But now I'm going to return something. What am I going to return? I am going to return a float. So instead of being a void function, this is going to be a float function, and that works quite nicely because it will return a floating point number, which will be put into area, which above is also defined as a float. So as I'm passing this ball around, if it's round, it needs to be coming through round holes, not square ones. Everything has to kind of match up as we're passing these parameters. So float, and what am I going to float? The function find area. Okay, now what do I need? I need to know what the length and the width is. So up here in the function, I'm going to pass what? Length, not there. Okay. Yeah, I already passed length and width. So what did I do? I threw length and I threw width. Well, if I threw length and width, I better catch them down here. But I want you to see I don't have to call it length here and width here because this is a new set of local variables. And just to make that explicit, I'm going to call them something different. So I'm going to go ahead and say it's going to be a float incoming. So I'm going to say float, and what will I call it? I'll just call it L. And then I will say float W. So what is this doing? This find area is expecting to get a floating point number, which it will put in the local variable L. And what is passed to it? Length, which is floating point, is going to come down, and that length is going to go into L. And the width, which is also a floating point number, is going to go into W. So what is this float business? This is saying float is L, float is W, And then what it is going to return later on will be float. So this float is totally unrelated to these two floats. This is just saying this function will return a floating point number. Now, what does it need? It happens to also, by coincidence, need a floating point L and a floating point W, but these don't all have to be floats. The floats are what's coming in, and the float is what is going out. So hopefully that makes sense. Now, what am I going to do here? I need to open my curly, open my clause, and close it. And now what does this do? I'm going to calculate an area. So I've got to create a variable, a local variable. It is going to be a float, and I am just going to make it A. I'm deliberately using different variable names, so it's very clear that these are independent variables local to the function or local to the void loop, and they're just being passed in and out. So float A. A is local to the function find area. Okay, now what does A equal? A is equal to L times W. Not length, not width. Those are variables that belong to the void loop. I'm going to put in L and W, which are the local variables to find area. Now, I don't have to put here float L and float W because I define them here. So they're defined here, so the program already knows what they are. I think I've got an extra parenthesis there. Okay, so now it hasn't seen A has not been declared, so I got to declare A, and then A is equal to what? L times W. Now what am I going to return? I'm going to return A. So what did I call this? A float. A float function, meaning it is going to return a floating point number. What floating point number is it going to return? A. So where does A come? A is returned right here, and then area is set to what value is returned. Does that make sense? I feel like I'm just repeating myself, but you gotta understand this. So I want to make sure that you understand it. Okay, so let's run this. Hey, looks like it might gonna run here. Looks good, doesn't it? Okay, done compiling. I'm downloading, and I'm gonna close that. Let's press the magic button and then input the length of your rectangle. I'm gonna say 3, okay? And then input the width of your rectangle. I'm gonna say 4. And then what does it say? 3 times 4 is 12. Your area is 12. Boom. So I passed a local variable to the function length. I passed a local variable to the function width. And then it took that. It read it in as an L and a W. It calculated A. It returned A. And then it put A into the variable. It put A into the variable area, which we printed out. Okay, so now we did that. Let's find perimeter. So I'm going to say float, find perimeter. What do I need? I need a float for the length, an L. I need a float for the W. For the W, which is width, I'm going to open and close my curlies. And then what do I need? This time I'm going to need a float, P for perimeter, and P is going to be equal to 2 times the length. Perimeter is the distance around, not S. P is equal to 2 times the length plus 2 times the width. And that should be the perimeter. Now I'm going to return what? The perimeter, like that. Now I'm going to have to call it up here, right? I'm going to have to call it. So I called the area is equal to find area. Now I'm going to say the perimeter is equal to the function find perimeter. What do I pass it? I pass it length and width like that. Okay, so I call that, That looks good. Now I need to make sure that I define perimeter up here. Yes, perimeter is defined in the void loop, so that's good. And then that's float. That looks good. That looks good. I return P. P should come into now. This should put that P value into perimeter. And then here I'll just get my print statement just because it'll make it a little bit quicker. And then I'm going to say your perimeter is P, right? No. P is the local variable down here. That is passed back up into perimeter like that. Okay, that looks good. Now what do we want to do? I found the perimeter, I found the area. Now I'll say float, and I want to find the diagonal. Find the diagonal. That's the distance between the upper right corner of the rectangle and the lower left corner of the rectangle. What am I going to need? I'm going to need, again, the float L, the float W, like that. And then I'll open and close my curlies. What am I going to do in here? I'm going to float. What am I going to find? The D for diagonal. And then what is the diagonal? The diagonal is going to be equal to the square root, SQURT, the square root of what? L times L, length squared, plus width squared. Okay, and what is that? That's the Pythagorean theorem. C squared is equal to A squared plus B squared. So that's saying the diagonal squared would be L squared plus W squared. And if I want the diagonal, then I take the square root of L squared plus W squared, which is the square root of L times L plus W times W. I think you could put like SQR of L and that would square it. Something like that would probably work as well, but I just don't have that on the top of my head. So I'll just do the old L times L this time. Now, what am I going to do? I'm going to return D, the diagonal, like that. Now up here, I have done the perimeter. Now, what was that? I thought I'd put my cursor up here, but I had not. Okay, so here at the bottom of the void loop, I'm going to come in, and now I'm going to say diagonal is equal to find diagonal, and I pass it L, and I pass it length and width like that. I'm going to open and close my curlies. Now, yeah, I don't need to open and close my curlies. This is a semicolon because I'm just finding the diagonal. And now I will take my print statement again because it's a pretty handy print statement. And then what am I going to do? I am going to Control V, and this time I'm going to say your diagonal. I like to use upper cases in here. Your diagonal is, and then I'm going to print diagonal like that. Now, anytime I do this, I always like to put down here after that last print a blank line just so when it runs it again, it'll be nicely formatted. So serial.println, open, close, semicolon. Okay, let's see what happens. I'm going to clear this out and I'm going to run this and have a sip of my coffee. Man, we're doing good. I haven't made a lot of mistakes today, have I? Okay. So let's press the old button. Okay, input the length. I'm going to say the length is 3. Input the width. The width is 4. Why do I do that? Because a 3, 4, 5 triangle is a magic triangle. So to check it, I know if one side is 3 and the other side is 4, I know that the diagonal will be 5. So you see, it's like a quick way for me to check my trig and make sure that it's working because I know what the answer is. So I'm going to put 3 and now a 4 and enter. And then your area is 12. 3 times 4 is 12. And then your perimeter is 14. 3 times 3 is 6. 3 plus 3 is 6. 4 plus 4 is 8. 8 plus 6 is 14. That is correct. And the diagonal is 5 because it's a 3, 4, 5 triangle. So you see, this is working, and now it asked me for the next length of the length of the next rectangle. But just look how elegant this is. Now if you look at my program, look at this. What I do is I enter the length, I enter the width, and then it's very clear. What I do is I find the area, I put that in area, and I print it. I find the perimeter, I put that in perimeter, and then I print it. And then I find the diagonal, I put that in diagonal, and then I print it. So you see how readable this code is? And then if somebody wants to look into the functions, they can come down here and look more explicitly about what those functions do. Okay, boom, that is one way. I passed the parameters down into the function between the parentheses, okay? So you pass things down like this. Length went down into L and width went down into W. So I pass the parameters down with variables between these two. They have to match in number. Like if I have length, width, height down below, I better be looking for 3 variables. They have to match, and they have to match in type. So you don't want to pass an integer into a float or a float into a string or something like that, okay? So they've got to match in length, they've got to match in the number and in the type. Okay, but there is another way that you can get things back. So I showed you that I could get things back by making a float type of function, or you could imagine an int type of function, or you could imagine a float, an int, a string type of function, right? But what I want to show you is I could also pass the parameters up and down using a void. So let's go back to void and let's see how that would be done. Void, okay? And then void, meaning I am not going to use these returns, right? I'm not going to return anything. I'm not going to return anything. And I'm not going to return anything. Now, the astute among you would say, wait a minute, wait. A is a local variable. You're using a void, and therefore up here on find area, it has no way of knowing what it is. Well, I didn't return anything, so I'm going to take that out. But how I'm going to do it, I'm going to return it as a parameter. So I'm passing down length and width, but what am I getting back? I'm getting back the area. What am I passing down here? Okay, I take that out. I'm passing length and width. And what am I getting back? Perimeter. And then I'm not returning anything, so I can't say diagonal equal, because find diagonal now is void. And so I'm going to come in and I'm going to pass down length and width, and then I'm going to return what? Diagonal, like that. Okay, and everything else should work. Now when I come down here, now I'm catching L, I'm catching length in the float variable L, I'm catching width in the float variable W, but what do I need to do here? What do I need to do here? Give me just a second. Give me just a second. Okay, what do I need to do here? I need to put the variable in, okay? And that is going to be a float A. And if I'm going to define float A here, I don't need to define it here. So this is going to catch length in L, it's going to catch width in W, and then this A is going to go back up. But I have to give it a little clue that this is what I'm sending back. And that is by putting an AND there. The AND A says, hey, I'm firing this one back up to you. thank you for the L, thank you for the W, but you'll be getting an A back. So this is sort of defining the direction as going back up. And this is also known as passing by reference. Instead of passing by value, it is passed by reference. So it's saying this A, the fact that I put that and there, is saying that that A will be coming up to this variable area. All right, and that'll just put that A very nicely into area. I find that a little bit awkward, but that is just the way it does it. So what do? I don't need to put the float P there. I need to put the float P here, but who's your friend? The at. P's coming at you. Hey, Mr. Whoever called find perimeter, you're getting P back and you're getting it as a parameter. All right. Now we're going to come in here and we are going to put the float D here. Float D. What is it? It's an at. It's a variable passed by reference, and it declares it there as well. And so that is all we need to do. Man, I hope I did that right. Let's run this thing. It's looking encouraging. It's downloading, and boom. Man, I hope this works. So now what we're going to say is 3, enter 4, okay? And then look at that. The perimeter, your area is 12, your perimeter is 14, and the diagonal is 5. Okay, so I've shown you 2 ways to pass parameters back and forth between your main void loop and function. One I did by using a float or an int type of function where I return something, and the other method is just putting everything as parameters. You know, I don't know which way I like best. I learned coding on Fortran, and Fortran really, I think, used a method more like this where you passed everything back and forth as parameters in the call and in the function like this. You did it more like this. But then after I started kind of getting used to doing it with a return value, I kind of started really liking the return value. And so I really think that I could do it either way. And probably now I don't particularly have a favorite way of doing it. Okay, guys, I hope you're beginning to see this is the right way to do it because your variables are local and you don't have one guy messing with some other guy's array or messing things up. Or let's say you had an I value in one function and then another function happened to use I as well and changed it, and then everything gets goofed up. Everything is very deliberate. All the variables are local, and we pass variables back and forth. The call is passing a value, and the function is catching it. Some things are done, and then it passes an answer back. The calling function catches it. So hopefully that makes sense. Okay, it's been a couple of weeks since I gave you a homework assignment, so you really need a homework assignment. When I give you these assignments, post them to YouTube. Down below, put a link over to your homework solution, and then in the description in your homework solution, link back to this video so people can see sort of where you came from. But this is the homework assignment. I want you to set up a potentiometer and an LED, and I want the brightness of the LED to be set by the position of the potentiometer. If the potentiometer is all the way to the left, the LED is off. If the potentiometer is all the way to the right, the LED is full bright, and I want it to smoothly transition between those values, those endpoints, and I want you to do it using functions. One function could, a logical way to do it would be one function could be read pot. The next function could be calc bright, like calculate brightness. And then the next function could be set LED or write LED. So you could kind of do a read, a calculate, and a write. And then that would be a real crisp, easy to read, easy to debug code in your main loop, and then you would have 3 simple functions down below. I hope you guys are having as much fun taking these lessons as I am making them. As always, I want to give a shout out to all of you guys out there that are standing with me on Patreon. Right now, it is my Patreons who are keeping me in the game. That is what allows me to keep making these videos and bringing you fresh new content every week. Thanks a lot, guys. You can also help me by leaving a comment down below, by leaving a thumbs up. If you have not already, subscribe to the channel. When you do, ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.